WAEC, JAMB, and IGCSE students, I want to show you quickly 3 important lift or elevators formula you can use in your examinations. But before we start, I want you to understand very quickly that the true weight of a person never changes. That's inside a lift now. The true weight of a person never changes. It remains the same. What a scale reading inside a lift will always measure is what we call the normal reaction of the floor of the lift on a person or a body inside the elevator. We call it the apparent weight. So now for our first formula, for a lift at rest or moving with constant velocity, if a lift is moving with constant velocity, we know from elementary physics that if an object is moving with constant velocity, it means acceleration is 0. So if that is the case, the apparent weight, which is r, minus the true weight, which is mg, will be equal to the resultant force. Of course, this is Newton's second law, ma. So if we replace acceleration with 0, it means that our normal reaction r minus mg, that's the true weight, will be equal to 0. So this implies that r is equal to mg. R is equal to mg. So by moving this here, this becomes a positive mg. So the implication of this formula is that inside a lift or an elevator, the apparent weight is the same as the true weight. Our second formula is for a lift that is accelerating upward. If a lift is accelerating upward, the normal reaction R will be greater than the true weight. And then again, it is equal to the resultant force. That's Newton's second law of motion. By moving this across, it means that R is equal to ma plus mg, which implies that R is equal to m bracket a plus g. That's by factorization. This is our second formula for a body inside a lift or an elevator. So the normal reaction or the apparent weight is greater than the true weight inside an elevator, meaning a body inside an elevator will feel or appear heavier. Then the third and the final case is for a lift that is accelerating downward. Now, if a lift is accelerating downward, it means the weight mg is greater than the normal reaction r, which is now equal to Newton's second law, ma. So if we rearrange these terms, it means that our r, that's normal reaction, will be equal to mg minus ma. So if we factorize quickly, it means our r is equal to m bracket g minus a. So this is the third formula for a body inside a lift or an elevator. So inside a lift that is accelerating downward, a person feels lighter. That is because the true weight is greater than the apparent weight. Remember I said earlier that inside a lift or an elevator, what a scale reading will measure is the apparent weight, not the true weight. True weight is always constant. It does not change. And then there is a last case. That's for a free falling lift. If a lift is falling freely, free falling lift, it means that the reaction force is always equal to 0. The reaction force is always equal to 0. So note these 4 situations or implications of the weight of a body in a lift. Thank you for your time, and see you in my next video where I will solve practical examples involving these formulas. Thank you.